Hello again, chemistry students. I thought I'd take this time to go through the book and do a couple examples of how to do these neutralization problems. I'm going to go ahead and do this out of the book. You can use this technique then to help you with the neutralization worksheet that I will send you. And so the two problems we're going to be doing are on page 664, numbers 44 and 45. So follow along with me, and so if you have any questions, just make sure to email me. And so let's go ahead and start with problem number 44. All right, and so for problem 44, I will read you the question, we'll set up the problem, and then we'll solve it. All right, what is the molarity of a nitric acid solution if 43.33 milliliters of 0.1 molar KOH solution is needed to neutralize 20.0 milliliters of the acid solution? All right. Again, before we do anything else in chemistry, we need to have the balanced chemical equation. So I'm going to go ahead and I will provide that for you. And so we're going to react nitric acid, which is going to have the formula of HNO3. So that represents our acid. We're going to react with that potassium hydroxide, which therefore would be our base. So remembering the Arrhenius definition of acids and bases. Remember that when you react an acid and a base, you form both a salt and water. And so the salt in this case is going to be potassium nitrate and H2O. And notice that for this problem, we're in luck because it's already been balanced for us. And so notice that the mole ratio is 1 to 1 to 1 to 1. And so we're going to go ahead then and solve this problem. Remember that molarity is defined as the moles over the liters. So remember that molarity is moles per liter. We need to find the moles first, and then we can then go from the moles of the KOH to the moles of the nitric acid, and then based upon the volume of the nitric acid, then we'll be able to calculate the nitric acid concentration. And so remember that we can rearrange this equation to solve for moles by multiplying both sides by liters. So mole is equal to molarity times liters. So again, we first have to find the moles of the potassium hydroxide. That will also be the same as the moles of the nitric acid. We take that, divide by the volume of the nitric acid, and that therefore will give us the volume as molarity. And so notice that in the problem, it tells us that we have 43.33 milliliters of 0.1 molar KOH. And so the first thing I need to do is convert the milliliters to liters. So I have 43.33 milliliters. Remember that there's 1,000 milliliters per liter. I'm going to put the liter on top, and the 1,000 milliliters goes on the bottom so that the units cancel out. Remember, if I'm dividing by 1,000, what that means is I move the decimal place to the left 3 places. So we're going to move this 1, 2, 3. So we're going to have 0.0433 liters. And so we've converted our milliliters to liters, remembering that there's 1,000 milliliters per liter. All right, we are going to look for the mole. We have to take the concentration of the potassium hydroxide and multiply by this liter. And so we're told that the concentration is 0.1 molar times 0.0433 liters. Notice I'm multiplying by 1/10, which is the same thing as dividing by 10. So I just have to move the decimal place to the left 1 place. This is going to give me 0.00433 mole of KOH. All right, so notice now To find the moles, I take the concentration, which is 0.1 molar, multiplied by the volume in liters, which is 0.0433, and so I end up getting 0.00433 mole of potassium hydroxide. Remember, everything in this equation is 1 to 1 to 1, so not only does this tell us the moles of KOH, it also tells us the moles of the nitric acid. So if we need 0.00433 mole of KOH to neutralize this reaction, we also are going to have 0.00433 mole of nitric acid. And so notice now, and so again, this is because we have reached what's referred to as the equivalence point, and the equivalence point is where the moles of the acid or base is equal to the moles of the base or acid. And so notice that these mole values are the same. All right, one final step. Remember that molarity is moles per liter. We have our moles now. We are told that we have 20 milliliters of the acid solution. 20 milliliters, we convert this to liters by dividing by 1,000. And so this becomes 0.02 liters. So again, I have to do a conversion to go to liters. To find the molarity, all I need to do then is take my 0.00433 mole and divide by 0.02 liters. And so 0.00433 mole divided by 0.02 liters. I will need a calculator at this point, so hold on just a second. So here's my calculator. I'm going to take 0.00433 divided by 0.02. And so when I do that, I'm going to end up with roughly approximately 0.22 molar HNO3. So I'm going to round this up to 0.22 molar HNO3. All right. And so I will stop here for a second so that you can get this down. And so notice again, we have to first find the moles of our base. Once we calculate this, this is also the same as the moles of the acid. We're told the volume of the acid, so that goes on the bottom, 0.00433 mole divided by 0.02 liter tells us we have a 0.22 molar HCl solution. And so that would be how you would do problem number 44. All right, we're going to do problem number 45, and then I will stop here, and then you can go ahead and proceed on with the neutralization worksheet. All right, let me go ahead and read you then the problem for number 45. Here's the question. What is the concentration of a household ammonia cleaning solution if 49.90 milliliters of 0.59 molar HCl is required to neutralize 25 milliliters of the solution? All right, let me go ahead and erase this, and then we'll write down the setup, and then we'll go through this problem step by step. So let me go ahead and erase this first. All right, so in this problem, we're reacting ammonia with HCl. So ammonia is our base, HCl is hydrochloric acid. And so let us go ahead then and write up the balanced equation. We have ammonia. Ammonia's chemical formula is NH3. NH3 plus HCl. And so notice in this problem, what we're going to have, this is our acid, and so it's going to donate the hydrogen over here. And so what we're going to end up forming, NH4 plus Cl minus. And so this is our ammonia, this is our hydrochloric acid. NH4 plus, as you recall, is going to be the ammonium ion. So this is the ammonium ion, and this is the chloride ion. All right. Notice that in this reaction, there's no water formed. However, I want to point out, notice again, everything is 1 to 1 to 1 to 1. And so what we need to do is identify what we have. So this is our base, this is our acid, this is our conjugate acid, and therefore this is our conjugate base. And so we're going to go ahead then and use this information to determine the concentration of the NH3. All right. And so again, just to remind you, molarity is moles per liter. Again, we can rearrange this to solve for moles by multiplying both sides by liters. So mole is equal to molarity times liters. All right, we're told it takes 49.90 milliliters of 0.59 molar hydrochloric acid to neutralize the ammonia. And so again, what we first need to do is convert between milliliters and liters. We have 49.90 milliliters. Remember that there is 1,000 milliliters in a liter. And so if 1,000 milliliters in a liter, to again solve this, we're going to move the decimal place to the left 3 places. 1, 2, 3. This is going to equal 0.04990 liters. And so now we're ready to calculate the moles of our hydrochloric acid. So we have 0.59 molar HCl times 0.04990 liter. And so at this point, I'm going to need my calculator in order to solve this problem. 0.59 times 0.04990. I end up getting roughly 0.029. So I get 0.0, let's say 0.03 mole of the HCl. All right, so our first step again is to calculate the moles of our known. And our known in this case is hydrochloric acid. So we take the molarity times the volume in liters, and we end up getting 0.03 moles of HCl. Remember that in this problem, everything again is a 1-to-1 mole ratio. So not only does this tell us the moles of HCl, this also tells us the moles of the ammonia. And so 0.03 mole HCl is also 0.03 mole of NH3. So again, because we've reached the equivalence point, the moles of the acid exactly match that of the moles of the base. And so we have 0.03 mole of NH3. To determine the molarity of the ammonia solution, again, molarity is moles per liter. So remember moles per liter. We calculated that we have just a second before I do that. The volume for the ammonia is 25 milliliters. So I need to convert that first to liters. Again, I need to divide this by 1,000, so I'm going to move the decimal place to the left 3 times. 1, 2, 3. So this becomes 0.025 liters. And so now I'm ready to calculate finally the molarity of the unknown ammonia solution. The molarity, in this case, we have 0.03 mole divided by 0.025 liter. And so remember, we got the 0.03 from here. This is our volume for our ammonia. We take 0.03, we divide by 0.025. And so when we do that, we end up getting a concentration of 1.2 molar ammonia, NH3. All right, so again to review, here's our balanced chemical equation. We first find the moles of our known acid by taking its molarity times its volume in liters, and so that gives us 0.03 moles. Because this is a one-to-one relationship, this amount of HCl is also the amount of base, so we have also 0.03 moles of the NH3. We convert the 25 mils to liters, and so then we take 0.03 mole, divide by 0.025 liters, and then we end up getting our final answer of 1.2 molar NH3. And so I'll go ahead and stop right here, and I hope that this made sense. Go ahead then and do the neutralization worksheet. It will look very similar to these two types of problems. I hope you guys have a good rest of your day, and I will talk to you guys again soon.